Welcome, students, and what we're working on is the hyperbola part of the conic section, and this should be our last section that we're going to cover, and then afterwards I'll give a project together so that you guys can actually develop and create a bubble wand. Just something about the bubble wand. It's not supposed to look like mine. It's supposed to be creative. It's supposed to include all the different parts of it. I'll move it out of the screen. As you can see here, there's 3 circles. There's an ellipse, there's a hyperbola, and there's a second hyperbola. So everything's inside there. If you haven't already printed the notes, I would strongly recommend to you print the notes. All the details are here. Here's the equation of the hyperbola, the center. Just notice, and I'm going to refer to like the whole fraction as either positive or negative. If x is positive, it will go left and right. If y is positive, then it will go up and down. H and k is still the center, and the vertices are still h minus a, k, h plus a, k, and then so on and so on. Make sure you have all the details written out. All right, let's go ahead and look at problem 1. So what you should notice from here is that the a value will always be the first one, whichever one is the positive. So just be careful if I do turn it around, pay attention. So the 1 is the a value and the b is the 16. Actually, b is 4, but 4 squared is 16. So just be aware of that. And you can figure out the foci here, the foci, the plural focus. It does look like Pythagorean theorem, as you can see there, and we'll probably get into the foci as you can see. There's multiple parts on this homework. So the first part here, they're asking, and I'm going to move this up a little bit here. They're asking, what are the vertices of this? So first of all, what we should notice is that the center, since there's really no plus or minus with the x and plus or minus with the y individually there, the center of this is 0, 0. This is the h value. This is the k value. Now, the way that we find the vertice then is take a in this case is the 1, and go ahead and add and subtract that to the h value. Well, that's kind of easy because when you take 0 plus 1, you get 1. And when you take 0 minus 1, you get negative 1. And notice the k value stays the same. And again, the hardest part about this is really just going through and typing in all the solution. Make sure I got everything set up there. Put a comma in between your ordered points, so just be careful with that. The foci, this is the information for the foci, just as the Pythagorean theorem. I'm going to do that in a different color here. It really, just a second, I want to make that look like a C. C squared equals a squared plus b squared. So if you look at it, a is 1, b is 4, but once you square them, so it's just going to be 1 plus 16, c squared. So obviously it's going to be the square root of 17. The foci, so just notice what they're saying there is that where is it located? And they're located, let me get this typed in here, square root of 17, 0, oh boy, I don't want to put all that in there. And then comma in between them, negative square root 17 out of it. And then there's my solution. So do take notice that whenever you take the square root, you should put this as plus minus. It kind of helps in the process. And which one is the graph? Well, since x is the positive part of this, it has to go left and right. So there's a few of these I can start to eliminate. It's either B or C. Now, when you look at it, we can actually make the graphs bigger. This does touch at 1 and negative 1, so that does look very promising there. If we make this one larger, it doesn't touch at 1 and negative 1. The vertices are going to be like where the hyperbola kind of bends and turns in the other direction. So from obvious observations there, that is the answer. All right, let's do one more problem. I'm going to look at 3 through 5. These are all very similar. So first we got to match up the graph, and then we got to locate the vertices and the foci, just like the last one here. So again, actually, let me see if I can find one where y is positive, x is positive, y is positive. We'll do one y is positive here. All right, the y is positive. When the y is positive, I'm referring to the whole fraction. Whenever I say y is positive, not just the individual. It's going to go up and down. So it's either going to be this one, it's either going to be B or C. just like the ellipse. Now, think about when you graph the ellipse, the center on this was 0, 0, and it went up and down 2, but left and right 5. In fact, I believe it's this one, but if you look at it, they are counting by twos, 2, 4, 6, 8, 10. As you can see, they go up 2, down 2. They go left and right 5, 2, 4, 5, 2, 4, 5. And so that is the solution. It's not this one because they're going left and right 2 and up and down 5. So you have to be kind of careful in the direction. So basically the y value still goes in the same direction there. Let's move on. The foci, let me scoot this up so I have a little bit more work. Again, the foci is going to look just like Pythagorean theorem. So when you look at this, it's going to be c squared equals 4 squared. Oops, I don't want the 4 squared in there. I just want 4 plus 25. If you want to write 2 squared plus 5 squared, it's going to end up the same way. C squared equals 29. So take the square root and you do get plus and minus the square root of 29. Again, what's nice about the problems I've set up, the center is 0, 0, so you don't have much modification moving around going on there. So when you look at this, it's going to be square root 29, comma in between, don't forget that, square root 29, close that off, check answer. Oh no, the foci are, and since this is going up and down, my foci are actually going to change the y values, not the x. I did it to the wrong one there, so I just had it backwards. Square root of 29, close that, 0, comma, negative, a lot of type in here. Get out of there. There, that's what I'm looking for. Had that backwards, so just be careful. And the equation of the asymptote. So real quick, I'm going to try to run through this fairly quickly so you can see the ending part of this. Here's the original graph. Whenever I graph the hyperbola, since the y value down here, the 4 down here is actually 2 squared. So since it's 2 squared, that means I'm going to go up and down 2. So I'm going to go up 2, down 2. And then since the x value over here, the denominator is 25, which means it's 5 squared. It's going to go right 5 and then left 5. Is that 4, 5? So technically what's going on here is that there's supposed to be like an imaginary box. You're not supposed to be able to see this box here. And that's basically what they're graphing here when they graph the box. Now, the way that they graph the asymptote is they actually intersect this, that corner with that corner. That corner with that corner. So you actually connect those corners. So it should go through the center and go in that direction, vice versa in the other direction. And really the hyperbola, since it's going up and down, these are kind of like asymptotes, and they're getting very, very, very close to the asymptote. Actually, I should touch that point there and touch that point. I was a little bit off there. So if you think of slope is just rise over run. It goes up 2 over 5. In fact, the other way is going up 2, left 5. So what's kind of nice about the asymptote, it's always going to be y equals, and the reason why they have the plus minus is because it's always going to be the same value. Up 2 over 5, positive direction, up to backwards 5, negative 5. So it actually is going to be 2/5, or you can just remember it as a over b, just don't square them, and then that's your final solution there. Oh, I forgot the x in there. Silly response. There's my solution. All right, if you have any other questions or concerns, definitely get a hold of me and we'll go through the problems. Thank you.